Good morning. We were discussing about the manufacturing of ceramic disc insulators used for high voltage transmission. Various methods or the flow chart which was used for the manufacture was discussed in detail. We will now look into the importance of the glass insulators, how the glass insulators are manufactured in the industry. So, the suspension glass insulators are used like a porcelain or a ceramic insulator for transmission and distribution purposes. These insulators have a very good contamination performance because of the self healing or cleaning properties. These glass insulators are very good for remote areas, in particularly where gun shooting or helicopter patrols are not of regular or the activity is not there. So, here in the glass insulator, the outer glass surface is normally under higher tension and compared to the inside glass sheds. So, any damage caused to the outer surface could cause violent shattering of the shell with the spontaneous failures in the line. Glass insulators are very attractive to shoot because the shell explodes when hit. So, some people take it as fun to shoot the glass insulator and shatter the insulators. Again, the shattered glass is a safety hazard. These insulators for transmission or distribution are not so popular in the United States. They are popular in Europe, Canada, Brazil and many other countries. In our country there are also several lines which we have used glass insulator for the extra high voltage and ultra high voltage transmission system. When you carefully look into the glass insulator, you can see the similar to a porcelain insulator, a glass insulator also has metallic end fittings on a pin and a cap and a glass shell of a particular petticoat depending upon the creepage length. You can see various types of glass insulators. These are normally without the petticoats or sheds, usually used in the desert areas where high wind could damage the petticoats or the porcelain or glass shells. So, we will be looking into how the manufacturing of the glass insulator, this is also very important to know that. So, manufacture of glass insulator again is a similar process like the porcelain or ceramic insulator, but here the materials which are employed for the manufacture of glass are basically the soda ash, field spar, then cullet. This could be a small pieces of glasses with minor amounts of other agents which are used. So, these materials are crushed to a powdered form, properly screened, measured and later on put into a storage towers. So, the mixture which is available in the storage towers is fed to the electric furnace. This undergoes a melting phase and then the fining phase what is known. Here the glass is at the molten stage where it is around 1400 degree Celsius, and the glass can be drawn at a known rate depending upon the heat input and the input feed to the feed of the raw materials. So, at known temperature, whatever specified temperature, the glass is normally, the molten glass is normally dropped into the cast iron mold and immediately this is pressed to the required shape. So, depending upon the shape, whether it is a normal insulator used for a normal conditions or the anti-fog type with the sheds, different sheds for the higher creepage length, or the insulators which are used for desert condition, basically known as aerofoil with no sheds. So, such mold is already prepared and the molten glass is drawn, and this is fed and to the cast iron mold, and immediately it is pressed to the required shape which is to be obtained. So, the molded shell later on is transferred to heat tempering followed by the thermal shock, where shells are normally dropped into the water basin. So, where water, so these shells which are not tampered properly or not being having some defects during this above process are observed visually and are collected and are normally inspected, and further process will never be done for these defected insulators. We should know that alumina is normally cemented and later on used for cementing, and insulator further are sent for proof testing both mechanically and further electrically. So, various testings are carried out at the factory, which are known as the routine type of tests, which we will be discussing in the future discussions. So, this conformal tests will be done according to the applicable standards, could be IEC, IEEE or national or European standards, and the insulators are tested. Further, after the testing confirmation, these insulators are put up in the form of a crate, where number of insulators are put in a crate and are shipped to the desired location of the utility. This is how the manufacturing process of the glass insulator takes place. So, what are the material hardware which are used along with the silica glass and other materials which we have discussed? These are basically the end fittings. How important is like the ceramic, we were discussing about the Portland cement, the end fittings, so on for porcelain insulator. Similar to that, the metal components are to be cemented to the glass shells which have been obtained. This provide a means of transmitting mechanical load which may apply to suspension insulators or post insulators or the insulators which are used in for the substation equipment production. So, usually malleable and ductile iron and forged steel protect usually against the corrosion are normally used for the hardware of pin and cap. So, these are initially nailed properly, and the casting is done by either grinding or machining and galvanizing. So, the surface in contact with the cement is properly coated with the bituminous paint. Further, steel forging is normally carried out for pins of the suspension glass insulators. These steel components are further galvanized and coated with bituminous paint to obtain more strength. So, this is important, that is one of the reason where galvanizing and coating with bituminous paint is carried out to obtain more strength. For some limited applications, the manufacturers also employ aluminum alloys which are used, but these are again not very economical. So, depending upon the usage and importance, so aluminum alloys are being used. So, cement, similar to the porcelain or the ceramic insulators, here aluminous cement in a very clear form, that is a neat form where it contains no sand, aggregate or filler in cement mix, is basically used for the assembly of glass insulators. So, in curing, aluminum trioxide Al2 with alumina is liberated from monocalcium aluminate phase. So, earlier in the Portland cement was employed for the porcelain or a ceramic insulator, there lime was liberated during a curing purpose. So, here it is alumina usually is liberated from the monocalcium aluminate phase in case of glass insulators, and there are no chemical reaction which takes place because of the galvanized insulator. So, there is need to coat the hardware with a bituminous layer, that is the reason where a bituminous layer is coated. And alumina which has a very high compression strength, adequate mechanical strength is developed after 24 hours after the curing in water and further to mechanical proof test. So, this is how the insulator cementing or insulator hardware are fixed to the glass shells in the manufacturing stage. This is again the flow chart of the discussion which we have just talked about various manufacturing stages. So, this shows the entire manufacturing process of the glass insulators, where you can see the raw materials are collected and stored. Further, these are powdered using the screening mechanisms. So, further to the screening, it is sent to the furnace where it is melted at a temperature. After the melting of the temperature, these are carefully molded using the mold cast iron moldings for different shapes or a required shape. Further, this a toughening to be made, it is sent for the firing, and after the firing the insulators are dropped in the chamber containing water. This further shells are taken out and are further assembled along with the cap and pin using a suitable coatings and the aluminous cement. Further, after finishing the product, the glass insulators undergo various mechanical and electrical tests at the factory, which are best known as a routine tests, and further the inspection and the quality measures are met. These insulators are packed properly in crates and are dispatched to the required locations. This is how the steps in the manufacturing of glass, a very important process for the glass manufacturing. So, when you carefully look here, this is how the shell or the insulator cut section of the glass insulator looks, typical schematic of the glass insulator, where you can see the cap. The cap again is a malleable iron, hot dipped galvanized iron which is used. You can see here a bituminous layer is being coated and alumina cement is used here for the jointing of both the cap and the glass shell. So, the toughened glass which is obtained from the molten state at a defined temperature, you can see various types of shells are normally employed. Further, there is again alumina cement which is connected to the pin of the insulator. So, the cap and pin of the insulator with the glass shell is embedded with the alumina cement coated with the bituminous layer. This is how the glass insulator looks. This is again a pin type of insulator normally employed for lesser voltages. Here again you can see the different pin insulators jointed with the help of alumina cement and a toughened glass shells, or it could be 2-3 shells which are jointed depending upon the voltage and the creepage requirement. And you have a zinc thimble which is basically to used for the having thread arrangements and used to mount on the poles. So, you have a threaded arrangement, this insulator could be mounted on the platform of the pole of the wherever the insulator are to be placed. So, further we have discussed about the manufacturing of the porcelain or a ceramic insulator, the glass insulator. Both are electrically and mechanically stable, very good, are being used for a very long period of time, more than a century old technology. A lot of changes have happened in both the ceramic and glass insulator pertaining to the voltage level, the creepage distances, the shapes have undergone several changes and are being used. Now, we will discuss about the recent or a decade or two or 3 decades since the polymer or the development of composite, a polymeric or a silicon rubber insulators, sometimes known as non-ceramic insulators. So, I will be using the terminologies either composite, polymeric, silicon rubber or non-ceramic during the discussion. So, these insulators are basically organic in nature and were first used somewhere in 1940s. The first polymers tried out for electrical insulations were bisphenol and cycloliphatic epoxy resins, which were introduced in mid 40s to 50s. Later on, cycloliphatic epoxies were introduced in late 50s, particularly for outdoor insulation. These were used in 60s or late 60s in England, later in France, Italy and US. So, lot of research activity has gone into this. There are being several advantages for going in this insulation. So, in Germany, these units were initially tested for in the field during the late 70s, late 60s and in early 70s. So, initially the manufacturers introduced the first generation polymers or commercial polymeric transmission insulators way back in 1970s, which are known as the first generation commercially available or polymeric transmission line insulators used for both transmission and distribution, initially tried out. So, several companies were available, most of the companies do exist, right, like Cerever, which use the housing material. EPR is ethylene propylene rubber, somewhere in 1975, this is in France. Then Hoyobras, Rosenthal, Sedever, TDL, Lab, Reliable. So, several of these companies started during the similar period of the 1975 to 1983 using either ethylene propylene rubber or the silicon rubber. So, these materials which are of organic in nature were being tried out in the initially stages, where the silicon rubber insulator looks like this. You have a metal end fittings, you have a silicon rubber housing, and from the metal fittings inside there is a fiberglass rod, which is again on the fiberglass rod this silicon rubber or the ethylene propylene rubber has been fixed. So, this is how the polymer insulator looks. So, we will look into how importance is the composite or a polymeric or a silicon rubber insulator, how easy or is it to manufacture, and the proper care which is to be employed for the manufacture and the transportation and so on. So, now as mentioned, non-ceramic insulators were introduced in 70s, particularly for transmission because of advantages. So, many people, many industries started the business of the polymeric or the composite or non-ceramic insulators, and these thought were to be used for all the voltages. The main advantages of the polymer or non-ceramic insulators being very light in weight, flexible, having a high mechanical strength to weight ratio. These insulators showed a strong intention and also low degree of standardization. So, very important. So, several advantages for both the manufacturers and the utilities. So, this is how a typical I am repeating the insulator looks. You have a metal end fittings, inside connecting from the metal end fittings is the fiberglass rod, then on the fiberglass rod the weather sheds or the silicon rubber or the composite material which is embedded on this rod. So, end fittings are properly crimped to the metal to the fiberglass rod. This is how the insulator looks. So, you have a uniform circumferential compression near this end fittings. You have a high reliability of the end fittings pressure, which is again taking care of the fiberglass rod here. A strong adhesion between the housing and the rod has to be done. So, there is a paint which is being made and also the silicon unit cast housing is done. silicon housing with which is an excellent hydrophobicity is normally used. So, this is how typical non-ceramic or a polymer insulator looks. How is the silicon rubber insulator manufactured? So, we have previously discussed about the manufacture of the glass and the ceramic or the porcelain insulator. We will look now into the importance and how the manufacture of silicon rubber and what is the care to be taken during the manufacture and during the transportation. So, before going into the manufacturing stage, what is the main composition of the silicon rubber or the composite material which are used for the transmission insulators are important. So, this compound which is I mentioned as an organic compound basically consists of a poly dimethyl siloxane which is known as a PDMS structure. So, poly in the sense several chains of this dimethyl siloxane structure is shown here. So, basically the silicon again which is consisting of oxygen and the methyl group. This again methyl group is an alkyl which is derived from methane which contains 1 carbon and 3 hydrogen atoms which are bonded. So, this is how the structure, and there are a number of structures in a silicon rubber PDMS structure. So, poly dimethyl siloxane with different functional groups that is OH, C, CH2, H and others are available consists of these groups. So, here apart from the silicon rubber PDMS there are fillers which are employed. These fillers could be of pyrogenic or precipitated silica, quartz powder and others. So, the vulcanizers which are used are peroxides and silicon. So, catalysts for the material used are platinum compounds, tin compounds and some others. So, what are the additives for this compound? Again they have adhesive agents, softening agents, various pigments, this is for coloring of the insulators and others. So, carbon blacks, the pigment types, conductive tape types and also the special types. So, aluminum trihydrate, aluminum hydroxide which is known as ATH is normally used as a filler materials for this silicon rubber. So, the percentage of the various fillers and the PDMS is decided by the manufacturer, and each manufacturer they have a special composition for the manufacturing of this compound. So, basically as mentioned earlier, the polymer insulator consists of a metal end fittings as shown here. This is a silicon rubber material and the fiberglass rod which is embedded here. Again silicon rubber initially is the sheds are important, uniform sheds were observed during the manufacture. Later on because of the advantages these sheds are of uneven in nature are being employed, that we will be trying to discuss in the future when it comes to the testing and the performance of this silicon rubber insulators. So, what are the steps involved in the manufacturing process of a silicon rubber composite or a polymer insulator? So, as mentioned raw materials we discussed used for this insulator are basically silicon rubber, the fiberglass rod and the metal end fittings. So, these metal end fittings which are employed for the insulator are to be cleaned with the help of ultrasonic cleaning process, where the metal end fittings are dipped into a liquid for a known time and are left for any kind of impurities present over the surface. So, cleaning of the impurities of the metal are very important fittings. So, these end fittings again undergo crimping and swagging, which is a step by step process of the crimping method. So, how the selection of material is done is to see that appropriate cleaned metal fittings above, which is done using the ultrasonic cleaning process, and the fiberglass rods are also selected. These cleaned metallic fittings are inserted into the identified fiberglass rods of known dimensions of known length. The metal to metal distance, which is also known as lip to lip distance, is maintained as per the prescribed gauge by inserting rubber or polypropylene cushion to ball side or socket side metal fittings, so that the damage is not caused during the crimping process. So, jaw setting is usually done by using the suitable jaws which are selected according to the diameter of the crimping portion and the crimping length, which is mounted on the crimping cavity. So, there are various settings which are done for the crimping, from the initial conditions to various crimping pressure, crimping mode and crimping knob settings. So, these are done at a proper pressure and as per the standards available for a particular dimension of the fiberglass rod. So, crimping mode settings can be either manual, semi automatic or automatic. So, the composite insulators which are presently being manufactured in the range of 90 kilonewtons to 160 kilonewtons or more, and for traction insulation crimping jaws are normally adjusted to a dia of 45 millimeter, length of 40 millimeter, and which for at 6 seconds time and a crimping pressure somewhere around 150 kg per centimeter. So, this is a typical example for the traction insulators of a particular length. So, this stages of crimping is also very important to be considered. Further, surface preparation, the surface of the fiberglass rod is to be made very smooth, and the surface is coated by using a diluted primer, which is a commercial normally available is Chemlock, where is applied to the sheds or housing and are properly attached to the fiberglass rod. These coatings help to maintain hydrophobicity, so that there is no erosion of the material or surface flashover which takes place. So, the applying of the material along with the end fittings and also heating in a oven to a temperature will help in the proper surface which further goes for the molding. So, where various molds molding arrangements were tried out, presently the injection molding is normally employed. This is suitable, and this injection mold is normally operated at 160 degrees, and number of sheds, the volume, pressure, curing time are normally provided under the standard specifications for a particular product. So, the molding is done usually in 3 stages, where the bed of the machine is cleaned by using a valve lapping compound and later by the jet of a compressed air. So, here again the curing process is done, so that this becomes hard, and rods are now housed using silicon rubber by the process. So, generally alternate type of sheds are preferred. So, earlier I have mentioned the point why the importance of alternative type of sheds. This is mainly to see in case of rain the continuous stream of water is discretized into droplets, reducing the frequency of flashover. So, if the sheds are uniform, because of the rain, the flashover because of the water droplets could form and reduces the creepage length. So, to ensure that the sheds are of alternative type, bigger and smaller are normally used. Then after the inspection molding, it goes for the insulator goes for the deep flashing. Here the insulator is placed on the racks or stacked in the wooden supports. After the component has cooled to ambient temperature, and some further sticking extra material, silicon rubber material which is extra is removed manually or by using a knife In case of traction insulator, 3 types. We have bracket insulator, which is for inclined purposes, 9-ton insulator, which is to maintain the horizontal position and also has to make it horizontal. So, the weight of a 9-ton is used, and a stray arm insulator to be in the horizontal process are normally used. So, testing routine tests after the insulators are ready, these have to undergo the routine test in the factory performed during the production before the crating and the shipment is done. So, these tests, mechanical or electrical or thermo mechanical tests will eliminate defective insulators which might either otherwise fail immediately upon installation and energization. So, in the factory before the dispatch, mechanical, electrical and other mechanical bending tests are usually performed before the insulators are dispatched. So, mechanical tensile strength, we will be discussing several of the tests. This is just to give a brief introduction about the mechanical tests. Usually here the testing fixtures with insulators are placed on the mechanical test bed connected in the form of a string. The number of insulators again will be decided by the amount of load to be applied. The stress which is to be applied varies 60% of the total mechanical of the insulator string for a time frame of a minute. So, the load is then realized and observed for withstand or failure in the factory. Similarly, appropriate electrical tests are carried out for a period of 1 minute, and in case of no flashover, this insulator deems to be cleared the particular test. Bending test, the again completion of mechanical and electrical tests, some are randomly selected and mounted to test bed for ultimate breaking load, and determined the value of breaking stress is usually calculated and found. So, after the electrical, mechanical and bending tests which are routine in nature, the insulators from the quality section is cleared for the dispatch, where after clearance for the insulators are normally stored horizontally in the crates properly with packing and fixing, and ensured that undue load is not exerted on the polymer sheds where they could damage if it is not properly taken care. So, this is how the process of the polymer insulator happens. The similar flow chart is shown here where it gives the metal end fittings, fiberglass rod, the silicon compound, the raw material silicon compound, fiberglass rod, metal end fittings are the required raw materials. This metal fittings as mentioned are cleaned with the ultrasonic arrangement where the impurities are completely eliminated. Further, the crimping of the metal end fittings and the fiberglass rod is done, and the coating, primer coating as mentioned, is done to the insulator surface to see a proper attachment of the silicon rubber is done on this. Then these are sent to the injection mold, where in the injection molding you have various types of insulators which are to be used, could be for distribution, transmission or the traction, suitable temperature, and the compound is being fed where depending upon the sheds this injection molding is being done and it is compressed. Further, the curing of the insulator is done and it is sent for various deflashing and various testing aspects, both mechanical, electrical, bending arrangements. So, this apart from this there are some other chemical and tests which are normally carried out. It could be the specific gravity, hardness testing, tensile strength, elongation of the rubber. So, all these tests apart from the electrical, mechanical, bending. So, the chemical and the surface changes which could take place are carried out, and finally this material upon the clearances after undergoing the mechanical, electrical testings, these are dispatched to the utilities for using in the transmission, distribution or in the traction purposes. So, we have till now discussed about the various procedures or various process involved in the manufacturing of the ceramic, glass and the recent insulators which are being used for transmission, the composite or a polymer insulators. So, various stages of the manufacturing have to be taken care, impurities which could be present during the manufacturing stage if left unnoticed could have a serious consequences in the field. So, every stage of the manufacturing process has to be carefully taken care and see the product is manufactured without any defects, impurities and so on. Further, after the manufacturing of the insulators, maybe the ceramic, porcelain, glass or the composite insulators, handling of this is a very important task, handling or managing of this overhead insulators either from the factory dispatch to the utility or the required place and how it is being handled for the stringing. So, each and every information is of very important. It is not that manufacturing is done in a very precise way and the usage or handling, if it is done poorly, then this could again see the insulator failures in the field. So, care has to be taken for proper handling or managing of this overhead insulators. Here we have few points which we will be discussing for all the three types of insulators. The first being the porcelain or the ceramic insulators. So, initially during transportation in the field, the porcelain insulator may cause damage from time to time in case if the handling is not done properly or a rough handling of this insulator is done. So, heavier insulators particularly like line post require careful handling. So, dropping crates of suspension or pin type while unloading from the truck should be taken care, as at field are common reasons where it could be damaged. Here the utility factor somewhere around 2% damage rate is estimated in the cost, and care has to be taken while loading and unloading, because a small damage or a hairline crack could result in the failure. So, insulators that are extensively damaged could be spotted, but sometimes it may also be difficult. So, hairline crack as mentioned or internal damage are not normally easily detected, and this could bring down the system. So, careful handling of this is very important. Vandalism, yes, compared to glass insulators, porcelain are not much attractive, and particularly for people who have a hobby of shooting the insulators in the field. So, each hit of this could reduce a shell, thereby marginally reducing the flashover. So, if dedicated vandal removes sufficient porcelain from each insulator of the string, then definitely the flashover occurs at the first onset of the wetting. So, compact line designs using porcelain or post insulators are normally vulnerable to line drops, which result, and the reports of the gunshot are seen. So, any single hit could cause a line post to shatter. So, vandalism, care has to be taken for a glass or the porcelain insulators. Similarly, for the glass insulator, handling is very important, where here the failure of glass insulators originates from the surface and is usually attributed to the micro cracks which could be present during the loading, unloading, and also the failure which could be seen. Normally the rate of suspension, burst rate of suspension range anywhere between 2 per 10,000 per, here sometimes it could go more than 15 to 20%. So, higher rates of the activity purge rate are normally reported during the construction of new lines and are handled in the field. So, handling of this is very important. People normally drag on the ground, and this could impact the small stones rocks or a hard sand, a hard soil where small chips could develop in the toughened glass or a polyester insulators, and this chip could act as a stress concentrator with moisture and thermal cycling. The insulator shell could eventually shatter. So, this has to be properly taken care while the stringing is being done. A proper insulator shifting of the insulator to the exact position without damaging or dragging has to be taken. And handling of glass insulators for vandalism, very lot of reports have been seen, particularly in North America, where they have good success with toughened glass, and other experience have very high rate of vandalism. So, on one hand, glass insulators are we say superior to porcelain and non-ceramic insulators. On the other hand, utilities do not favor glass insulator due to high rate of vandalism, because there will be a flashover and a lockout on the permanent fault. So, this is one of the major concern pertaining to the glass insulators. Coming to the handling of the composite insulation. So, as mentioned, composite insulation, silicon rubber on the outer shed, I am again repeating, the fiberglass rod between the metal end fittings. So, these non-ceramic or composite insulators can easily get damaged through handling. So, very important, and damage to housing during transportation. So, crates which are made for the transport have to be carefully considered, where the overlapping of the silicon rubber sheds do not happen and mechanical forces do not exert on the silicon rubber. So, once damage to the housing, the effects of moisture and the voltage stress could result in two possible failures, which will be discussed. It could be the tracking along the core or the brittle fracture, very serious to the non-ceramic insulator. So, during installation there are reports of cracking of the core because of the cantilever or torsional loading of the insulators. Tracking of core again depends to the extent of the core which is exposed, a location of the damage which is relative to line end, wetting, and also amount of the local environmental pollution or a contamination which exists at that place. So, brittle fracture failure also could happen if the damage is near the line end of the insulator due to the production of nitric acid, particularly during the corona discharges, combination of the moisture. So, these corona discharges from the end fittings like the corona control rings, and if the microstructure failures during the crimping could cause, and if there is damage near the line end where the water seeps in, nitric acid formation and brittle fracture issues are also noticed in the long rod composite insulators which are used for EHV and UHV transmission. So, brittle fracture at center of insulator or at the structure end are rarely reported. Again this could be because of the end fittings, because of the corona, because of the water seepage, because of the crimping at the ends. So, this could be the reasons for not many failures observed at the center of the insulator or at the structure. Vandalism, again here non-ceramic composites suspension and line post insulator, this could withstand a severe gunshot without electrical or mechanical damages, and these are generally not easy to locate for the gunshot in the field because of the structure of these insulators, as brittle fracture of the core is accomplished by the line drop. Insulators in hunting areas should be inspected regularly, that is in case polymer insulators are employed where people are prone to shoot these insulators. So, regular inspecting is essential for EHV and UHV lines. So, we have discussed about the manufacturing of various insulators, porcelain, glass and composite insulation. which are used for the transmission systems. We have also discussed about the material handling, the insulator handling, the transportation, the dispatch, and how importance is or the care to be taken during the stringing of the insulators. We will discuss about the design criteria and the insulation coordination in the next class. So, thank you.